Okay, so now I'll start the new method to use regular expression in iOS XR device. Okay, so till this point, what we have done a filtering on iOS XR device using the iOS method, right? And on iOS device, we have done the filtering using regular expression. Now we'll be using regular expression, but using a different method, we'll do the filtering. Using AS path, we'll do the filtering, but a different method. So till this point, we were using the expressions, but now we'll be using some keywords to do the same task. Okay. Now, first of all, I'll check how many routes we are getting the route from the neighbor, do show IP BGP. So as we can see here, we are getting the routes 1, 2, 3, and 4. So these are the routers R1, 2, 3, and 4. These are the part of different AS number 100, 200, 300, 400. Okay. Finally, R4 should receive all the routes. So let's verify here also. So yes, getting all the routes 1, 2, 3, and 4. Okay. First of all, I'll configure a route policy to match those criteria, to match those parameters. Route policy, regular expression. Okay. Now, if AS path. Now, so earlier we did in. It means in. So once I'll start using in, it means we can use a method that is a old method of iOS devices, right? But now I want to use a different mechanism to do the same task. Now we can see is local. If AS path is local, then pass, else, drop, and if. Okay, it means whenever this device will find any route that is having a local AS, then it will pass, otherwise it will drop everything. It means it will find one single route. So I'll just configure first of all, say exit, show IP BGP. So which is the local AS? So this is the local AS route, right? This is originated in this AS. So the device will match using this method is local. If that is local, if the route is local, it will pass, otherwise it will drop everything, right? Router BGP 300. Now my neighbor, the neighbor is 34004. Using physical addresses, we have configured the neighborship here. Now address family IPv for unicast. So whenever we need a change, we need to configure a policy or we need to apply the policy here. So we have to go into the address family IPv for unicast. Now route policy, the name is regex. I'll put in out direction. It means whenever I will send the information out, it will check if the route is local, then only that will pass, otherwise it will drop everything. And just put the commit. Go here. Now, what we should receive? Only the route that is 3.3.3.3. And look here. We are getting a route that is 3333. That's it. It means what the device is doing here. The device is sending only the local route. So this is how we can send a local route. Okay. Next. So now I'll just modify this route policy. Route policy regex. If AS path now. So that was local. Now I'll match the length of the ASs. Length equal to, greater than, is, less than. Okay. So let's say I'll match greater than, equal to. If that is 1, let's say 2. If that is 2 or higher, just match, then pass, else drop, and if exit and put commit here. So now do show IP BGP. What we can see here, right now we just have one single route that is having 2 ASs, right? So what we have configured GE2, greater than is equal to 2. It means if that is 2 or higher than 2, just pass. It means now we'll find a single route, and now R4 should receive a route 1.1.1.1. And look here. Now we are just getting a single route that is 1.1.1.1. Okay. Now if I'll change the number, let's say I want to match one, at least one, and more than one. Okay. So if I'll match single one, it means it will start sending the routes 2 and 1, right? So I'll just modify again. 1, exit, commit. Now we should receive 1 and 2 also. Okay, perfect. So now what we are getting here, we are getting 1 and 2. So if I'll match the length equal to, less than, is, equal or less than, so it will match all the criteria. Okay, now let's check the other mechanism. If A is path, so this we have done, length we have done, neighbor. So this is saying if the neighbor is this one, it means if the last AS is 200, it means from left to right, right? If that is 200 or that is 300, just match. So right now, who is my neighbor? Only 200 is my neighbor, right? So I have to say here, if neighbor is in the single quote, that is 200, then pass as drop, and if, now I'll just say commit. It means right now it has a single neighbor that is 200. So if that is 200, just pass the update. So now we should receive 1 and 2. Perfect. We're getting 1 and 2 because in this one, do show IP BGP. Let's say I'm getting a route 200 from the neighbor 200, 200, 300, 400, 500. But we are matching only 200. So whatever routes we are getting with 200, 200, it will allow the routes. It means it will match this octet. That is kind of 200 and this expression, right? Start from 200, sorry, the end of 200 and then any number, that doesn't matter. The same here we have. Now I'll again modify this one. If A is path, so this we have done if the neighbor is, right? If I'll match the neighbor 100 to 300, 400, that will never match anything here. Now I will match here originate from. It means it will start checking this one, right? So now I will just use 200. If that originate from 200, it means kind of this mechanism, right? This expression. So if that originate from 200, then pass as drop, and if say exit and just say commit here. Okay, now what we should receive? We should receive only 2.2.2.2, right? And perfect. So now we are getting a route that is originated from 200. So if I will do here 100, so it will match this one that was originate from 200, sorry. Okay. So this is how we can match this one. Now let's move to the next point. If A's path passes through, it means that kind of mechanism. Match your A's and this one. If you find this A's, just pass the update. So now I'll mark 200. If you find a A's number 200 in any update, just pass the update. Then pass as drop and if say exit, commit. So now how many routes it will be sending? It will be sending 2 routes. It will find 200 here, 200 here. So it will send 1 and 2 to the neighbor, right? So now we should receive 1 and 2, and look here. We are getting here the route 1 and the route 2. Okay, let's move to the next step. If A's path, now the final one, the unique length. So now I'll explain you what is a unique length meaning. So if that is length or that is unique length. Now I'll explain the difference between length and unique length. So let's say we have some example. Let's say we have a route that is having 100, 200, 100, 100, 200, 300, and 400. And we have 100, 200, 300, 400. Okay. So if I will say length and any number 1, 2, 3, or 5, so it will start checking these and these also. No worries. It will never check anything, any special thing. It will just check the length. That's it. But if I'll check unique length, so it will be having these things, but it will just count 100, 200, 300, and 400. It means what it will do? It will check, okay, these numbers are the same, so I'll count just one single ace. I will never count these three a's as three different a's. I'll just count a single ace. It means a unique length. So what is unique length from this? So the unique length is 100, 200, 300, and 400. Otherwise, the mechanism is exactly same. So if a's path, unique length, again it's the same thing, equal to, greater than, is exactly match. Okay, so let me match exactly. If the unique length is, so what we are getting here, if the unique length is 2, exactly 2, then okay, the number 2 we have to use, then pass as drop, and if exit, put commit here. Now what we should receive? Only the route 2.2.2.2. Sorry, 1.1.1.1, because we have to match two unique length. So only in this one we are getting two unique length, that is 1.1.1.1, and here we are getting 1.1.1.1 on R4. So this is how we can use these parameters for the same task that we have done using expression, but now what we have here, we have some keywords to do the same task. So this is how we can do the filtering on the behalf of these parameters that are same as the expression.